Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in this session we are going to discuss physics solutions of NEET 2016 paper 2 and we have 45 questions here. So let's start the session. The first question is from the chapter Ray Optics and Optical Instruments and the question is a person can see clearly object only when they lie between 50 centimeter and 400 centimeter from his eyes. In order to increase the maximum distance of distinct vision to infinity, the type and power of the correcting lens the person has to use will be. Okay, so this is the eye, suppose this is the eye of the person. The range within which this eye can see the object clearly is 50 centimeter and 400 centimeter. Okay, that means the maximum distance up to which this eye can see is 400 centimeter. That means this is the far point of this eye. Why we are making this range on the left side of the eye? So this is by convention that we always assume that the object is kept on the left side of the eye. Okay, so you also have to do this. Now according to the question, we have to increase the maximum distance of distinct vision to infinity. That means we have to make this eye capable of seeing an object that is kept at infinity. Okay. Now, how will this eye see an object which is kept at infinity? But we know that this eye can see only up to 400 centimeter. So, if we make this the image of this object at 400 centimeter, in that case, will the eye be able to see the object? Yes. Okay. So we have to assume that the object distance is infinity. So this is given in the question. It is infinity. And since we assume that the object is kept on the left side of the eye, it will be minus infinity. Okay, minus sign for the left side. Now, image is also formed on the left side of the eye in this case. So it will also be in minus. And where will the image be formed? At 400 centimeter. Okay. In that case, what will be the focal length? That we have to find out. Okay, so we'll use the lens formula. According to the lens formula, one by v minus 1 by u equals to 1 by f. Okay, so we are trying to find out the focal length of the lens that will be able to make the image at 400 centimeter. Got it? So let's write it down. What is the image distance v? It is minus 400. Okay, so we can say minus 4 meter. Okay, minus 400 centimeter means minus 4 meter. So we'll take in meter minus 1 by u. So u is infinity equals to 1 by f, that is the focal length of the lens. So from here we can say that 1 by f will be equal to minus 1 by 4 meter. Okay, so f will be equal to minus 4 meter. Now minus sign in focal length means the type of lens is concave lens. Okay, it is a concave lens. Now we have to find out the power of the lens as well. Okay, type is concave lens and the power of the correcting lens will be power is equal to 1 by focal length. That means 1 by minus 4 and the unit will be diopter for power. So it will be minus 0.25 diopter. Now if you look at the options, you can see that there is some misprint in the options. Okay, so the first one will be your convex. In the option it will be convex. In the second one also it will be convex. In the third and fourth it will be concave. Now according to our solution, the type is concave and the power is minus 0.25 diopter. That means option C will be the correct answer. Okay. Question number 47 is from the chapter Wave Optics and the question is a linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated normally by a parallel beam of wavelength 5 into 10 to the power minus 5 centimeter. The distance of the first dark band of the diffraction pattern from the center of the screen is. Okay, so suppose this is the aperture. We know that the width of the aperture is taken as small d. Then there will be a screen at a certain distance from here. This distance is taken as capital D. Okay. Now what is given in the question? It is given that the width of the aperture is 0.02 centimeter. That means small d is equal to 0.02 centimeter. That is equal to 2 into 10 to the power minus 2 centimeter. Now this aperture is placed immediately in front of a lens of focal length 60 centimeter. So this lens will focus the rays of light at a distance of 60 centimeter. Okay, that is focal length. Okay, and we also know that this will be focused on the screen whose distance is capital D. Okay, so in this case capital D is equal to the focal length of the lens, that is equal to 60 centimeter. Then wavelength is given as 5 into 10 to the power minus 5 centimeter. We have to find out the distance of the first dark band of the diffraction pattern. So for minima, dark band means we are talking about the minima. So for minima, y equals to lambda into capital D by small d. Okay, so let's put the values and solve. Lambda is 5 into 10 to the power minus 5 centimeter. Capital D is 60 centimeter. And small d is 2 into 10 to the power minus 2 centimeter. Okay, so 2 into 30 will be 60. Okay, here we get 5 into 30, that means 150 into 10 to the power minus 5 plus 2 centimeter. So 150 into 10 to the power minus 3 centimeter, that means 0.15 centimeter. Okay, so option A will be the correct answer. Okay, next question is from photoelectric effect, that is from the chapter dual nature of radiation and matter. And the question is, electrons of mass m with de Broglie wavelength lambda fall on the target in an X-ray tube. The cutoff wavelength lambda naught of the emitted X-ray is. Okay, so we know that kinetic energy will be equal to hc by lambda naught. Okay, let's say this is equation number 1. Also we know that kinetic energy will be equal to p square upon 2m. Okay, and we know that p is equal to h by lambda, so we can put this value here. It will be h square by lambda square upon 2m. Okay, let's say this is equation number 2. Now both are kinetic energy, that means equation 1 is equal to equation 2. Okay, equation 1 equals to equation 2, that means hc by lambda naught equals to h square by 2 lambda square m. From here we can find the expression for lambda naught. Okay, this h will cancel this square, so we'll get lambda naught equals to c into 2m lambda square by h. Okay, so we can rearrange it and it will be 2mc lambda square by h. So this will match the option. Which option? Option number B. Okay, lambda naught equals to 2mc lambda square by h. So this is your correct answer. Okay, option number B is the correct answer. Now question number 49 is again from the chapter dual nature of radiation and matter, and the question is, photons with energy 5 electron volt are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectrons is 2 electron volt. Now when the photons of energy 6 electron volt are incident on cathode, then no photoelectrons will reach the anode A if the stopping potential of A relative to C is. Okay, so there are two cases here. Let's write it as case 1 and case 2. In the first case, the energy of the emitted photoelectrons is given as 5 electron volt, whereas the maximum kinetic energy of emitted photoelectrons, that is Ke max, is given as 2 electron volt. Okay, but what is the work function? That we can find out using the formula E equals to 5 plus Ke, where phi is the work function. Okay, so phi equals to E minus Ke. So energy of the photon is 5 electron volt and the kinetic energy of emitted photoelectrons is 2 electron volt. So 5 minus 2, that is 3 electron volt. This is the work function of the metal. Now in the second case, the energy of the photons is 6 electron volt. Okay, E is equal to 6 electron volt. So as we can see that energy in the first case was 5 electron volt, but this time it is 6 electron volt. So this is changed. That means the maximum kinetic energy of the emitted photoelectrons will also change, but the work function will remain same, that is 3 electron volt, because the metal or the photoelectric cell is not changed. Okay, the cell is same. So what will be the kinetic energy of emitted photoelectrons? Again we will use the same formula to find it out. So kinetic energy of the emitted photoelectrons will be equal to energy of the photons minus the work function. Okay, so energy is 6 electron volt and the work function is 3 electron volt. So this is 3 electron volt. Okay, this is the kinetic energy of the emitted photoelectrons. Now it is given that when these photons are incident on the cathode C, then no photoelectrons will reach the anode if the stopping potential of A relative to C is, okay. So we have to find the stopping potential of A relative to C. So we'll use the formula. Kinetic energy will be equal to EV naught, where V naught is the stopping potential, okay. V naught is the stopping potential. So kinetic energy is 3 electron volt. 3 electron volt EV equals to EV naught. So E is cancelled. What will be the value of V naught? V naught is equal to 3 volt. Okay, V naught equals to 3 volt. This is the stopping potential, but this is the stopping potential of C with respect to A, because the photons were incident on C, right? But we have to find in this question the stopping potential of A relative to C. So it will just be the opposite. Okay. So it will be minus 3 volt for C, of A with respect to C. Of A with respect to C. Okay. So minus 3 volt will be the correct answer. Okay. So option A will be the correct answer. Question number 50 is from the chapter Atoms, and the question is, if an electron in a hydrogen atom jumps from third orbit to second orbit, it emits a photon of wavelength lambda. When it jumps from the fourth orbit to third orbit, then the corresponding wavelength of the photon will be. Okay. So again here are two cases, case 1 and case 2. In the first condition, the electron jumps from third orbit to second orbit. That means N1 is equal to 2 and N2 is equal to 3, right? And in the second case, it jumps from fourth orbit to to the third orbit. That means N1 is equal to 3 and N2 equals to 4. Okay. In the first case, the wavelength is lambda. Wavelength is lambda. Now we know that 1 by lambda equals to R 1 by N1 square minus 1 by N2 square, right? So 1 by lambda equals to R 1 by N1 square, that is 2 square, so 1 by 4, minus 1 by 3 square, that is 9. Okay, so here we get LCM will be 36 and here we have 5. Okay, so 5 by 36 R, that means what will be the value of R? It will be 36 by 5 lambda. Okay, this is the value of R. Let's say this is equation number 1. Now let's come to the second case. Here again we'll use the same formula. Let's say that this time the wavelength is lambda dash. So 1 by lambda dash equals to R 1 by N1 square minus 1 by N2 square equals to R 1 by N1 square, that is 3 square, so 9, minus 1 by 4 square, that is 16. Okay, so in solving this, LCM will be 144 and the difference here will be 7. Okay, so 7 by 144 R. So what will be the value of lambda dash? Because in the question the wavelength is asked, right? So lambda dash in this case will be equal to 144 by 7 R, right? This is equation number 2. Now in the option you can see that the value of wavelength of the second case is given in terms of the lambda. Okay, so let's put the value of R from equation 1 here. Okay, lambda dash equals to 1 by 144 by 7 R, and R is equal to 36 by 5 lambda. Okay, so 36 and 5 lambda will go up. On solving this, 36 into 4 is 144 and 4 into 5 will be 20. So 20 by 7 lambda. Okay, this is the value of lambda dash. So 20 by 7 lambda, that means which option will be correct? Option number D will be the correct answer. Okay. Question number 51 is from the chapter Nuclei, and the question is, the half-life of a radioactive substance is 30 minutes. The time in minutes taken between 40% decay and 85% decay of the same radioactive substance is. Okay. So what is half-life? It is the time taken for the decay of half of the nuclei. Okay. Now here we have to find the time taken between 40% decay and 85% decay. Okay, so 40% decay, we are talking about the decay, right? 40% decay to 85% decay. Suppose the time taken is t. Okay, if we write it in terms of remaining nuclei instead of decay, okay, remaining. So 40% decay means how much remaining? 60% remaining, right? And 85% decay means how much remaining? 100 minus 85, that is 15% remaining. Let's say the time taken is t again, because both are same statements, only the method is different. Okay, the first one is written in terms of decay and the second one is written in terms of remaining, but the time taken will be same. Okay, so here 60% will first decay and how much will remain? 30% after one half life. Okay, because we know that in one half life half of the substances get decay, half of the nuclei get decayed. Okay, so 30% will be decayed and 30% will remain. Again after one half life, how much will remain? 30. So out of 30, 15 will decay and 15 will remain. Okay, so from 60% to 15% nuclei, how many half-lives are required? 2 half-lives are required. Okay, and one half-life is 30 minutes. So 2 t half will be equal to the time taken. Okay, and that is equal to 2 into 30 minutes, that is 60 minutes. So option A will be the correct answer. Question number 52 is from the chapter Semiconductor Electronics, and the question is, for common emitter transistor amplifier, the audio signal voltage across the collector resistance of 2 kilo ohm is 4 volt. If the current amplification factor of the transistor is 100 and the base resistance is 1 kilo ohm, then the input signal voltage is. Okay, so what is given here? The audio signal voltage is given as 4 volt. So this is the output voltage. Okay, it is 4 volt and the output resistance is 2 kilo ohm. So our output is 2 kilo ohm. Then the current amplification factor is given, that is beta, and we know that beta, current amplification factor, is equal to output current by input current. So that is given as 100. Okay, the base resistance, that means the input resistance, is given as 1 kilo ohm and we have to find the input signal voltage, that is input voltage. Okay, so this we have to determine. Now we know that voltage is equal to resistance into current, right, or current into resistance. So output voltage will be equal to output resistance into output current, and input voltage will be equal to input resistance into input current. Okay, so output voltage by input voltage will be equal to output resistance by input resistance into output current by input current. Okay, now let's put the values here. Output voltage is given as 4 volt, so 4 by input voltage is unknown, that we have to find out. Okay, output resistance is given as 2 kilo ohm and input resistance is given as 1 kilo ohm. Okay, then output by I input, that is beta, is equal to 100. So this is also given. This ratio is equal to 100. Okay, so from here we can write that input voltage is equal to 4 divided by 2 into 100, that is 200. So it will be equal to 1 by 50, and 1 by 50, that means 0.02 volt, but in the options millivolt is given. Okay, so 0.02 volt, that means 20 millivolt, isn't it? So which option will be the correct one? Option C, 20 millivolt, will be the correct answer. Question number 53 is again from the chapter Semiconductor Electronics, and the question is, the given circuit has two ideal diodes connected as shown in the figure below. The current flowing through the resistance R1 will be. Okay, so look at this diagram. You can see that there are two diodes D1 and D2 and three resistances R1, R2 and R3. So we have to find the current flowing through the resistance R1, that is this 2 ohm resistance, right? Now here you should know one thing, that a diode has a positive terminal. This triangle part is the positive terminal and this straight line is the negative terminal. Okay, so this is P side, this is N side. right? Now, if the positive terminal of the diode is connected to the positive terminal of the battery and the negative terminal of the diode is connected to the negative terminal of the battery, then this is known as forward biasing. Forward bias. And in this case, it does not oppose the flow of current. That means current will flow in this direction. Okay. Whereas in the opposite case, that means the positive terminal of the diode is connected to the negative terminal of the battery and the negative terminal of the diode connected to the positive terminal of the battery. In that case, it will be a reverse bias. Okay. Reverse bias, and it will oppose the flow of current. Okay. Oppose the current flow. That means current will not flow. So let's see, in the given diagram, the diode D1, here you can see that it is the negative side of the diode, that is the straight line is towards the positive side of the battery. Okay, this is the 10-volt battery. This is the positive side, this is the negative side. So positive side of the battery is towards the negative side of the diode and negative side of the battery is towards the positive side of the diode. That means D1 is reverse biased. Reverse biased. Okay, that means no current will flow. No current will flow through which resistance? Through R2 resistance. Okay, through R2. And if we talk about the D2 diode, this one here you can see that the positive side of the diode is towards the positive side of the battery and the negative side towards the negative side of the battery. So D2 is forward biased. That means current will flow through which resistances? R1 as well as R3. Okay, through R1 and R3 resistances. Now we have to find the current that is flowing through R1. So we can see that R1 and R3 are in series combination. Okay, so R equivalent will be R1 plus R3, that is 2 ohm plus 2 ohm equals to 4 ohm. Okay, so current will be V by R equivalent. Potential is 10 volt and the resistance, equivalent resistance is 4 ohm. So it will be equal to what? 10 upon 4, that means 2.5, and the unit of current will be ampere. So 2.5 ampere, that means option B will be the correct answer. Okay, this is the same current that will flow through R3 as well. Okay. Question number 54 is also from semiconductor electronics, and the question is, what is the output Y in the following circuit when all the three inputs A, B and C are first 0 and then 1? Okay, so there are two cases here. In the first case, all the inputs are 0. All inputs are 0. And in the second case, case 2, all inputs are 1. All inputs are 1. Now here you can see that the two inputs A and B are passing through the gate P, and this is the AND gate. Okay, and the output of the P gate along with the input C are passing through the Q gate, which is a NAND gate. Okay, because here there is a NOT. Now in the first case, the inputs of P gate are 0 and 0. Okay, A is 0 and B is also 0, and these two are passing through the AND gate first. So the output will be 0, because if both the inputs of AND gate are 1, then only the output will be 1. Okay, so since none of them is 1, so it will be 0. Now this output along with the input C, which is also 0 in this case, are passing through the NAND gate. Okay, NAND gate. Now if it would have been an AND gate, then the output would be 0, but since this is NAND and we know that NAND behaves just opposite to AND, therefore the output will be 1. Okay, so the output in the first case will be 1. Now if we talk about the second case, in this case A is equal to 1, B is also 1, both will pass through the AND gate, so the output in this case will be 1. Okay, because in AND gate we have already seen that if both the inputs are 1, then only output will be 1. Okay, now the third input is C, which is also 1 in this case. Okay, because here all the inputs are 1. So this C and the output of AND gate both pass through the NAND gate, right? NAND gate. Now, if 1 and 1 would pass through AND gate, in that case, the output would be 1. But since this is NAND, just opposite to AND, so it will be 0. Okay. So, in the second case, the output will be 0. So, in the first case, it is 1 and the second case, it is 0. That means option D will be the correct answer. Now question number 55 is from the chapter Units and Dimension, and the question is Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Which of the following combinations of these has dimension of length? What does it mean? It means that the dimension of length should be equal to the dimension of certain combination of these three quantities. Okay. Now let's assume that the power of h is a, that of c is b, and that of g is c. Okay, so we have to find the values a, b and c here. Okay, now on the left hand side we have the dimension of length. So what will be the dimension of length? It is m0, l1, t0. On the right hand side, what will be the dimension of h, that is Planck's constant? We know that the dimension of Planck's constant is same as that of angular momentum. Okay, so the dimension of h will be what? That of mvr. That means m lt minus 1 into L. So it is equal to m L2 t minus 1. Okay. This is the dimension of Planck's constant. So m L2 t minus 1. The power is A. Then c is the speed of light in vacuum. What is the dimension of speed of light? It is Lt minus 1. Okay. So Lt minus 1. The power we have assumed is B. Okay. And then the last one is gravitational constant. What will be the dimension of gravitational constant? We know that the gravitational force is equal to G m1 m2 upon r square. So from here we can say that G equals to Fr square upon m1 m2. So what will be the dimension? The dimension of force is mlt minus 2. R square means L square and m1 m2 means m square. So it will be m minus 1 L3 t minus 2. Okay, this is the dimension of gravitational constant. So let's put this value here, m minus 1 L3 t minus 2, and the power we have assumed is c. Okay, so c. Now keep in mind that we have to determine the values a, b and c. Okay, let's arrange them and bring all the quantities together. Okay, same quantities together. So first m, what will be the total power of m on the right hand side? It will be m to the power a minus c. Then L, what will be the total power of L? It will be 2a plus b plus 3c. Similarly for t, it will be minus a minus b minus 2c. Okay, we have just simplified it. On the left hand side we have m0, l1 and t0. Now what is important here? That the total power on a quantity, that means m, l and t, will be same on left hand side and right hand side, because the dimensions are same, right? So what is the power of m on the left hand side? It is 0. On the right hand side it is a minus c. That means a minus c equals to 0. So from here we can say that a is equal to c. Let's say this is equation number 1. Now we know that the value of a is same as that of c. Okay. Now if we compare the power of t, we are taking the power of t. What is the power of t on the left hand side? It is 0. On the right hand side, it is minus a minus b minus 2c. Okay. So minus a minus b minus 2c equals to 0. Okay. So let's solve this. We can say that minus a minus b minus 2a equals to 0, because from equation 1 we have seen that a is equal to c. So in place of 2c we can write 2a, right? So what do we get on solving it? Minus a minus 2a, that means minus 3a. Okay. So minus 3a minus b equals to 0. So what will be the value of b from here? B will be equal to minus 3a. So we have got the value of b as well in terms of a. This is equation number 2. Now we'll use the power of L. Power of L. So what is the power of L on the left hand side? It is 1, okay, because length has the dimension L. So on the left hand side it is 1. On the right hand side it is 2a plus b plus 3c. 2a plus b plus 3c. Okay. Now in place of 3c we can write 3a, right? So 2a, and in place of b what can we write? What we can write? We can write minus 3a from equation 2. B equals to minus 3a. So minus 3a, and in place of 3c we can write 3a. So 3a and minus 3a cancelled. This side we have 1, right? 1. So 2a equals to 1. That means the value of a is equal to half. Okay. So now we have got the value of a. So we can put the value of a in any equation to find the value of b and c. Okay. So if you put this value of a in the other equations and find the value of b and c, then you can say that the value of a will be half. The value of b will be minus 3 by 2, because b is equal to minus 3a. Okay. So minus 3 into half will be minus 3 by 2. Okay. And the value of c is same as that of a. So it will also be half. So these are the values. So let's write the equation that we had written initially. We know that the dimension of length was same as the dimension of a combination of h, c and g, right? And the power of h was a. So a is equal to half here. Okay. The power of c was assumed to be b. That means minus 3 by 2. And the power of g was assumed to be half. Again, sorry, this is c. So that is also half, right? So how can we write this combination? We can write it like this. H to the power half. That means it will be in the form of root. Okay. So under root h and g is also having the power half to h and g upon c to the power minus 3 by 2. So it will go on the denominator side, and c to the power 3 by 2. Minus means it will go to the denominator side. So the correct expression will be under root h into g upon c to the power 3 by 2. Okay. So let's see. Under root, can you see option number B? Under root h into g upon c to the power 3 by 2. Have we got the same expression? Yes. So option B will be the correct answer. So this is an easy question but a lengthy one. So you have to practice it well. Okay. Question number 56 is from the chapter Motion in a Straight Line, and the question is, two cars P and Q start from a point at the same time in a straight line and their positions are represented by xpt equals to at plus bt square and xqt equals to ft minus t square. So at what time do the cars have the same velocity? Okay. So for the first car, let's write it down here. For the first car, we know that the equation is xpt equals to at plus bt square, right? So x is the distance traveled. So what will be the velocity? Velocity will be the differentiation of this. That means d at plus bt square by dt. Okay. On differentiating it, what do we get? We'll get a plus 2bt. You know the basic of differentiation. So let's write it as equation number 1. Now for the second car, xqt equals to ft minus t square. F is also a constant, right? So what will be the velocity for q? It will be d ft minus t square upon dt. So on differentiating it, we'll get f minus 2t, right? This is equation number 2. Now it is given that we have to find the time at which they have same velocity. That means this velocity, the first one and the second velocity will be same. Okay. So let's equate these two equations. First one is equal to the second one, right? That means a plus 2bt will be equal to f minus 2t. Simple. And we have to find the value of t from here. So what we can write here? Let's bring the t together. Okay. So 2bt plus 2t equals to f minus a, right? If we take 2t common, it will be b plus 1, right? And this side we have f minus a. So what will be the value of t? T will be equal to f minus a upon 2 b plus 1. Okay, so this is the required time. So let's see which option is the correct one. F minus a upon 2 b plus 1. Which option? Option number A. F minus a upon 2 1 plus b or b plus 1. So option A will be the correct answer. Question number 57 is from the chapter Motion in a Plane, and the question is, in the given figure, a equals to 15 meter per second square represents the total acceleration of a particle moving in the clockwise direction in a circle of radius r equals to 2.5 meter at a given instant of time. The speed of the particle is, okay, so this figure represents the circular motion of the particle. It is moving in the clockwise direction, okay, it is shown by the arrow. Now, this is the acceleration, direction of the acceleration, and this is given as 15 meter per second square, right? Now, this acceleration is making an angle 30 degree with the center. So, if we resolve the acceleration into its component, so along the tangent, it will be a sine 30 degree, and along the center, it will be a cos 30 degree, okay? These are the components of the acceleration, right? So we can write that the tangential acceleration will be equal to a sine 30 degree, whereas the centripetal acceleration AC will be equal to a cos 30 degree, right? Now the formula of tangential acceleration is a into r, where a is the angular acceleration and r is the radius, and the formula of centripetal acceleration is v square by r, okay? Mv square by r is the force, so this is v square by r, where v is the speed of the particle, r is the radius. Now here we have to find the speed of the particle. That means we have to use this one, centripetal acceleration. We don't have to use the tangential acceleration, okay? So we can write that v square by r will be equal to a cos 30 degree, okay, because the centripetal acceleration is a cos 30 degree. We have to find the value of v. So v square will be equal to a cos 30 degree into r, okay. A, that means acceleration is given as 15 meter per second square, into cos 30 degree will be equal to 0.86, into radius is given as 2.5 meter, okay. So on solving this, we'll get 32.25, and we have to find the velocity or the speed. So speed is equal to under root 32.25, so we'll get approximately 5.7, and the unit of speed will be meter per second. So 5.7 meter per second, that means option D will be the correct answer. Got it? Question number 58 is from the chapter Laws of Motion, and the question is, a rigid ball of mass m strikes a rigid wall at 60 degree and gets reflected without loss of speed as shown in the figure below. The value of impulse imparted by the wall in the ball will be, okay. So it is given that there is no loss of speed. That means the magnitude of speed will remain same, but the direction is changing, isn't it? So we can resolve the components of speed into the x component, that is v cos theta, and the y component, that is v sin theta, right? This is along the y axis and this is along the x axis. Theta in this case is 60 degree, okay? The angle is 60 degree. So v cos 60 degree and v sin 60 degree. So along the x axis, the initial speed is v cos 60 degree, and the final speed will be minus v cos 60 degree, okay, because direction will be just opposite. This is the initial direction and this is the final direction, okay. So this is v cos 60 degree and minus v cos 60 degree, okay. So what will be delta v? It will be v cos 60 degree minus v cos 60 degree. So it is v cos 60 degree plus v cos 60 degree, that means 2v cos 60 degree. Got it? Similarly for y-axis, the initial direction is like this and the final direction is also like this, okay. It is not going upward. So the initial speed along the y-axis, we are talking about the component of speed, okay. So initial speed will be v sin 60 degree and the final speed will also be v sine 60 degree. The direction is not changed in this case. So what will be the delta v? It will be v sine 60 degree minus v sine 60 degree. That means 0. Okay. So the speed along y-axis is 0. That means we have to consider the speed only along the x-axis. Okay. What we have to find? We have to find the value of impulse imparted by the wall. So impulse means change in momentum. Okay. So mass into delta v. So mass, it is given in the question, no, it is given as m only. So m into delta v along the x-axis is 2v cos 60 degree. So into 2v cos 60 degree. What will be the value of cos 60 degree? It will be 1 by 2. Okay, it is 1 by 2. So m into 2v into 1 by 2, that means m into v. Okay, mv is the value of impulse. So option B will be the correct answer. Question number 59 is from the chapter Work, Energy and Power, and the question is, a bullet of mass 10 gram moving horizontally with a velocity of 400 meter per second strikes wooden block of mass 2 kg which is suspended by a light inextensible string of length 5 meter. As a result, the center of gravity of the block is found to rise a vertical distance of 10 centimeter. The speed of the bullet after it emerges out horizontally from the block will be. Okay. So we have a wooden block of mass 2 kg. Okay. This block is suspended by a light inextensible string of length 5 meter. This is 5 meter length. Then what happens? A bullet comes here. Suppose this is the bullet. Now the mass of the bullet is 10 grams. That means 10 to the power minus 2 kg. And it comes with a velocity of 400 meter per second. And it hits the block. Okay. After getting hit by the bullet, the center of gravity of the block rises a vertical distance of 10 centimeter. That means the block will move at this position. Okay. And then bullet emerges out horizontally from here with some other velocity. Okay. Because after hitting the block, its velocity will change. Let's say this is V2. So we have to find the value of this velocity. Okay. Final velocity of the bullet. Got it? Now I am taking the mass and velocity of the bullet in small letters. Okay. Bullet, the mass I'm taking in small letter m and velocity small v. Similarly for block, I'm taking capital letters. So capital M for mass and capital V for velocity. Okay. So don't get confused. Now here we'll use the law of conservation of linear momentum. Okay. So according to the conservation of linear momentum, total initial momentum will be equal to total final momentum. Okay. Total initial momentum equals to total final momentum. Total initial momentum means what? Initial momentum of bullet plus initial momentum of the block. Okay. That means m1 v1 plus capital M1 capital V1. Okay. Equals to total final momentum means final momentum of the bullet plus final momentum of the block. That means m2 v2 plus capital M2 capital V2. Got it? You have to pay attention, otherwise you'll get confused. Okay. Now what is the mass of the bullet? It is 10 to the power minus 2 kg. So 10 to the power minus 2 kg, and the initial velocity of the bullet is 400 meter per second. So we can write it as 4 into 10 to the power 2 meter per second. Okay. So this is the initial momentum of the bullet. Plus we know that initially before getting hit by the bullet, the block was at rest, right? So its initial momentum will be 0. Okay. So I'm not writing anything here because initial momentum of the block is 0. Okay. So this is equal to final momentum of the bullet, that means 10 to the power minus 2 kg into the final velocity is unknown, that we have to find out, right? Plus the final momentum of the block. So the mass of the block is 2 kg, and what is the final velocity of the block? Initially the block was at rest before getting hit, but after the collision, let's write it down here, after collision, or you can say just after collision, the block will have some velocity. Okay, just after the collision, block will have some velocity, but no So it will have the kinetic energy but no potential energy. But after it rises to a certain distance of 10 centimeter, then it will have the potential energy but no kinetic energy. Okay, because after coming at this height it will stop. That means total energy will be conserved. So initially it had only kinetic energy, that means half mv square, equals to finally it has only potential energy, so mgh. Got it? So from here we can find the velocity of the block. Okay, so m will be capital because we are taking capital letter for the block, right? So m will be cancelled, it is on both sides. So v will be equal to what? Under root 2gh. Got it? So this is the velocity of the block. Let's put the value. Under root 2 into acceleration due to gravity is 10 and height is 10 centimeter. That means 10 into 10 to the power minus 2 meter. Okay. On solving this, we'll get root 2. That means the final velocity of the block is root 2 meter per second. Okay. So let's put this value here, root 2. Okay. Now let's just solve it. 10 to the power minus 2 and 10 to the power 2 will be cancelled. So 4 equals to 10 to the power minus 2 v2. v2 we have to find out, plus 2 root 2. Okay. Now 4 minus 2 root 2 will be equal to 10 to the power minus 2 v2. 4 minus 2 root 2, on solving this, you'll get the value approximately 1.2. Okay. It will be 1.178, but let's write it as 1.2. It will be the approximate value. Okay. You know that root 2 is equal to 1.414. So put that value and find it out. Equals to 10 to the power minus 2 v2. We have to find v2, so v2 will be equal to 1.2 divided by 10 to the power minus 2, or we can write into 10 to the power 2. Okay, so it will be 120 and the unit for velocity will be meter per second. So what is the final velocity of the bullet with which it emerges out horizontally? 120 meter per second. Okay, so let's see. Option number D has 120 meter per second. So option D will be the correct answer. Okay. You just go through this solution again if you don't understand, because you need to pay a lot of attention. Okay. Question number 60 is from the chapter Systems of Particles and Rotational Motion. And the question is, two identical balls A and B having velocities of 0.5 meter per second and minus 0.3 meter per second respectively collide elastically in one dimension. The velocities of B and A after the collision respectively will be. Okay. So there are identical balls, that means they have same masses. Okay. But the velocities are different. The velocity of A is given as 0.5 meter per second and the velocity of B is given as minus 0.3 meter per second. That means the direction is opposite. Now it is also given that they collide elastically. That means this is an elastic collision. So here you have to remember one fact. On elastic collision, let's write it down here. On elastic collision between two masses moving with finite velocities, their velocities will get exchanged. Okay, their velocities, this is the most important thing, will get exchanged and they'll travel in opposite direction. Okay, they travel in opposite direction as they were initially. That means if we talk about the ball A, its velocity was 0.5 meter per second. So it will be exchanged with the second one. That means its velocity will become minus 0.3 meter per second. Why minus? Because initially it was in positive direction. So this time it will be minus. Okay. And the velocity of B will become 0.5 meter per second. This time it will be positive because initially it was negative. Okay, so direction will change as compared to the initial direction and the velocities will be exchanged. Okay, so the question is that the velocities of B and A respectively. Okay, so first we have to write the velocity of B and then A. So B is 0.5 meter per second. So first we'll write 0.5 meter per second and then A, that is minus 0.3 meter per second. That means option number C will be the correct answer. Okay. Question number 61 is from the chapter Work, Energy and Power, and the question is a particle moves from a point minus 2 I cap plus 5 j cap to 4 j cap plus 3 k cap when a force of 4 I cap plus 3 j cap Newton is applied. How much work has been done by the force? So what is the formula for work? That is equal to vector F dot vector S. Okay, F is the force and S is the displacement. Okay, so what will be the displacement in this case? It will be the final position vector minus initial position vector. Okay, final position is 4 j cap plus 3 k cap, 4 j cap plus 3 k cap, and the initial position is minus 2 I cap plus 5 j cap. So on solving this, we'll get 2 I cap minus j cap plus 3 k cap. Okay, so this is your displacement. So we'll put these values here. Force vector is 4 I cap plus 3 j cap. So 4 I cap plus 3 j cap dot product 2 I cap minus j cap plus 3 k cap. Okay, so in dot product we simply multiply the same components. Okay, so I cap will be 4 into 2, that is 8, minus 3 into 1, so 3, plus k component in force is 0, so it will be 0. Okay, so 8 minus 3, that is 5, and the unit of work done will be joule. So 5 joule, that means option D will be the correct answer. Question number 62 is from the chapter Systems of Particles and Rotational Motion, and the question is two rotating bodies A and B of masses m and 2m with moments of inertia IA and IB, where IB is greater than IA, have equal kinetic energy of rotation. If LA and LB be their angular momenta respectively, then okay. So it is given that the kinetic energy of the body A is equal to kinetic energy of body B. And we know that in rotational motion, kinetic energy is equal to half I omega square. So half IA omega A square is equal to half IB omega B square. Okay. So it is given in the question that IB is greater than IA. But this quantity half Ia omega A square is equal to half IB omega B square. That means for this to be equal, omega of A should be greater than omega of B. Okay, then only it will be balanced, right? Now, we know that angular momentum is equal to I into omega. So this side, on the left hand side, we can write half Ia omega A into omega A, right? Omega A square can be written as omega A into omega A. Similarly, this side, half IB omega B into omega B. Now this IA into omega A, it can be written as angular momentum LA. Okay, so half LA into omega A equals to half LB into omega B. Now we have seen that omega of A is greater than omega B. So in order to balance this equation, the L of B should be greater than L of A. Okay, angular momentum of B should be greater than angular momentum of A. So the correct relation will be option number D. Okay, option number D is correct answer. Now question number 63 is again from the chapter Systems of Particles and Rotational Motion, and the question is a solid sphere of mass m and radius r is rotating about its diameter. A solid cylinder of same mass and same radius is also rotating about its geometrical axis with an angular speed twice as that of the sphere. The ratio of their kinetic energies of rotation will be, okay. So we have a solid sphere and a solid cylinder. These two have same mass and same radius, but they have different angular speed. And the angular speed of solid cylinder is double the angular speed of sphere. Okay, so if the angular speed of solid sphere is omega, then the angular speed of solid cylinder is 2 omega. Okay, now what will be the kinetic energy of the sphere? Kinetic energy of the solid sphere will be equal to half I omega square. Now what is the value of I for solid sphere? It is 2 by 5 mr square. Okay, so half 2 by 5 mr square into omega square. Okay, so on solving this we'll get 1 by 5 because 2 will be cancelled. 1 by 5 mr square omega square. Okay, similarly kinetic energy of solid cylinder equals to half. What is the value of I, that is moment of inertia for solid cylinder? It is half mr square. Okay, so half mr square into what is the speed, angular speed, 2 omega. Okay, so 2 omega square, right? Now if we solve it, this 2 will be cancelled with here 2 will be left. Okay, because square is there, so it will be 4 omega square, so 2 will be left and this 2 will cancel this 2. Okay, so it will be m r square omega square, right? Now we have to find the ratio of these two. This is the first one, this is the second one. What will be the ratio? Let's see. Ratio of the kinetic energies will be 1 by 5 mr square omega square upon mr square omega square. So omega square will be cancelled, r square will be cancelled, m will be cancelled. That means 1 by 5 will be the answer. That means 1:5 is the required ratio. Okay, so option C will be the correct answer. Question number 64 is again from the chapter Systems of Particles and Rotational Motion, and the question is, a light rod of length L has two masses m1 and m2 attached to its two ends. The moment of inertia of the system about an axis perpendicular to the rod passing through the center of mass is. Okay, so we have a rod of length L. Suppose this is the rod. Okay, this is the rod, length is L. Two masses m1 and m2 are attached to the two ends of the rod. Okay, suppose this is the center of mass, then we have to find the moment of inertia of the system about an axis that is perpendicular to the rod and passes through the center of mass, that means this axis. Okay, now suppose the distance of mass m1 from the center of mass is L1 and the distance of mass m2 from the center of mass is L2. Okay, and the position of m1 mass is 0, that means origin. Okay, so x and y both are 0. So what will be the position of m2? It will be L and 0 because y component is 0. This is along the x axis and the distance from the origin is L because the length of the rod is L. Okay, now what will be the moment of inertia of the system? It will be equal to m1 L1 square plus m2 L2 square. But this is not given in the options because in options it is in terms of the total length L, not in terms of L1 and L2. So we have to convert L1 and L2 in terms of the total length L. Okay, so L1 will be equal to what? M1 x1 plus M2 x2 upon M1 plus M2. Okay, M1 x1 is 0, right? So 0 plus m2 into x2 is L. So L upon m1 plus m2. So we can say that L1 is equal to m2L upon m1 plus m2. Okay, so this is the value of L1. Suppose this is equation number 1. Similarly, we can find L2. So L2 is equal to what? Total length L minus L1, right? If we subtract L1 from the total length, we'll get L2. So total length L minus L1, that means minus M2L upon M1 plus M2. Okay, so let's open the bracket. LCM will be M1 plus M2. This side we get, will multiply L with M1 plus M2. So M1L plus M2L, then minus we have M2L. So plus M2L and minus M2L will cancel out. We'll get M1L upon M1 plus M2. Okay, so this is the value of L2. L2 is equal to M1L upon M1 plus M2. Okay, so we have got L2 as well. This is equation number 2. Now we'll put these values in the equation for moment of inertia. Okay, so let's write that equation again. We know that moment of inertia I is equal to M1 L1 square plus M2 L2 square. So let's put the values of L1 and L2. M1, L1 is what? M2L upon M1 plus M2 and square of this. Okay, L1 square is there plus M2 L2 square, that means square of this, M1 L upon M1 plus M2 whole square. Okay, Now we just have to solve this and we'll get the moment of inertia. So m1 into square of this will be what? m2 square L square upon m1 plus m2 whole square, plus m2 into square of this, that means m1 square L square upon m1 plus m2 whole square. Okay. Now on the numerator side we can take m1, m2 and L square common. So what will be left here? M2 plus this side m1. Okay. And on the denominator side we have m1 plus m2 whole square. So m2 plus m1 and m1 plus m2 are same things, right? So this will be cancelled out. Okay, square will cancel. So what will be left? m1 m2 L square upon m1 plus m2. Okay, so this is the moment of inertia. m1 into m2 into L square upon m1 plus m2. So let's see which option has this. m1 into m2 into L square upon m1 plus m2. So option B is the correct one. Okay. Although option C is also same, I think there is some printing mistake here because both are same. But anyways, this is the correct answer. Okay. Question number 65 is from the chapter Gravitation, and the question is, starting from the center of the earth having radius r, the variation of g, that is acceleration due to gravity, is shown by. Okay. So we know that inside the surface of the earth g varies directly with the distance. Okay. And outside the surface of the earth g varies inversely with the square of the distance. Okay. So if we draw the graph like this, then inside the surface, that means till here, radius, this is the radius. Okay. So till here it will be directly proportional with the distance, and after that inversely with the square of the distance, that means like this. So this will be the type of graph. So let's see, first one is not correct, second one is also incorrect. Now third one, yes, third one is correct. Yes, third one is correct. Okay, so option C will be the correct answer. Question number 66 is again from the chapter Gravitation, and the question is, a satellite of mass m is orbiting the earth of radius r at a height h from its surface. The total energy of the satellite in terms of g naught, the value of acceleration due to gravity at the earth's surface is. Okay, so we have to find the total energy of the satellite in terms of acceleration due to gravity, that is g naught. Okay, and we know that the total energy is equal to minus g, that is gravitational constant, into mass of the earth into mass of the satellite upon 2 r plus h, where r is the radius and h is the height. Okay, so we have to find the total energy in terms of small g, not in terms of capital G. Okay, so we'll convert it in terms of small g. Let's multiply and divide this by r square. Then what will happen? We know that small g is equal to g into m. M is the mass of the earth upon r square. Okay, so g into capital M upon r square, that means this part will be equal to small g. Okay, small g naught actually, because here in the question it is given that acceleration due to gravity is g naught. Okay, so we'll put this value minus, in place of gm by r square we'll write g naught, and what is left? Small m, r square is left, and here 2 r plus h is left. Okay, so now we have got the total energy in terms of g naught, that is acceleration due to gravity. So let's see which option will be the correct one. The third option, right? Yes, this is the correct option. Option number C. Now question number 67 is from the chapter Mechanical Properties of Fluid, and the question is, a rectangular film of liquid is extended from 4 cm into 2 cm to 5 cm into 4 cm. If the work done is 3 into 10 to the power minus 4 joule, then the value of surface tension of the liquid is. Okay, so the initial surface area is 4 cm into 2 cm, that is 8 cm square. This is S1. And the final surface area is 5 centimeter into 4 centimeter, that is S2 is 20 centimeter square. So what will be the change in surface area? Delta S will be 20 minus 8 centimeter square, that is 12 centimeter square. In meter square it will be 12 into 10 to the power minus 4 meter square. Okay, but this is a rectangular film and we know that film has two surfaces. Okay, two surfaces. So the change in surface area will be 12 into 10 to the power minus 4 meter square into 2. Okay, so it will be 24 into 10 to the power minus 4 meter square. Okay, this is the change in surface area for the rectangular film. Okay, now we know that the work done is equal to surface tension into change in surface area. Okay, work done is given in the question. It is 3 into 10 to the power minus 4 joule. Surface tension is unknown, that we have to determine. Delta S we have just calculated, it is 24 into 10 to the power minus 4 meter square. Okay, so what will be the surface tension? That will be equal to 3 into 10 to the power minus 4 upon 24 into 10 to the power minus 4. So 10 to the power minus 4 will be cancelled. 3 by 24, that means 1 by 8. Unit will be Newton per meter. Okay, and this can be written as 0.125 Newton per meter. So the correct answer will be option C. Okay, 0.125 Newton per meter. Now question number 68 is again from the chapter Mechanical Properties of Fluid, and the question is three liquids of densities rho 1, rho 2 and rho 3 with rho 1 to rho 3 in decreasing order having same value of surface tension T rise to the same height in three identical capillaries. The angles of contact theta 1, theta 2 and theta 3 obey. Okay, so we have to find the correct sequence. Now we know that the rise of a liquid in capillary tube, that is H, is equal to 2t cos theta upon rho gr. Okay, H is the height to which the liquid rises in the capillary tube. T is the surface tension. Okay, this is surface tension. Theta is the angle of contact. Rho is the density that is given in the question. G is acceleration due to gravity that remains constant, and R is the radius of the capillary tube. Okay, radius of capillary tube. Now it is given in the question that they have same surface tension. Okay, so tension T is same. Then they rise to the same height. That means H is also same. When H is same, this complete expression, this overall expression will be constant. Okay. It is also given that the capillaries are identical. That means the radius of the capillary will also be same. And acceleration due to gravity also remains constant. So cos theta upon density rho will also remain constant or same in all three. Okay, so cos theta will be proportional to density. Now it is given that the density is not same, it varies. Okay, and rho 1 is greatest, then rho 2 and then rho 3 is minimum. So in order to balance this, theta 3 will be maximum, then theta 2 and then theta 1. Okay, so which one will be the correct one? Theta 3 maximum. So in the first one, theta 1 is shown as maximum, so this is not true. In the second also, this is not true. In the third one, theta 1, then theta 2 and then theta 3. Okay, theta 3 is maximum here. So yes, this is correct, and the range is 0 to pi by 2. Okay, that is 90 degrees, 0 to 90 degree. So this is the correct sequence. That means option C will be the correct answer. Question number 69 is from the chapter Thermal Properties of Matter, and the question is two identical bodies are made of a material for which the heat capacity increases with temperature. One of these is at 100 degrees Celsius while the other one is at 0 degrees Celsius. If the two bodies are brought into contact, then assuming no heat loss, the final common temperature is. Okay, so we have two bodies. This is the first body, this is the second body. Okay, and these two are identical. That means they will have the same mass. Okay, now the first body is at temperature 100 degrees Celsius, so theta 1 is 100 degrees Celsius, and the second body is at 0 degrees Celsius, so theta 2 is 0 degrees Celsius. Now these two bodies are brought into contact, so what will happen? Heat will start flowing from higher temperature to lower temperature. That means from first body to the second body. Okay, for what, for how long? Until there is a common temperature between these two. Okay, so until a common temperature, let's say theta, is reached. Okay, this is the common temperature. So we have to find this final temperature, that is the common one. Okay, now we know that during this process of flow of heat from first body to second body, the heat lost by the first body, heat lost by the first body will be equal to the heat gained by the second body. Okay, heat gained by 2. This is the fact that you have to remember. Okay, so this question is based on this fact. Now heat lost by the first body will be equal to mass into specific heat of the first one, C1, into delta theta 1. Okay, that means change in temperature of the first body, equals to mass of the second body into specific heat of the second body into the change in temperature of the second body, that is mc2 delta T2. We know that mass is equal, okay, same. So mass can be cancelled out from here. Now C1 into delta theta 1, what is the change in temperature of the first body? So initially it was 100 degrees Celsius minus the common temperature that is reached. Okay, we are finding the change in temperature after a common temperature is reached. Okay, this side we have C2 and delta theta 2. So it will be common temperature theta minus 0 degrees Celsius, because 0 is the minimum value. Okay, so here we can write that C1 by C2 will be equal to, this side we have theta minus 0, that means theta upon 100 minus theta. Okay, now it is given in the question that heat capacity increases with temperature. Okay, so heat capacity, according to the question, heat capacity is proportional to the temperature, and heat capacity means mass into specific heat. Okay, this is proportional to the temperature theta. So which body has higher temperature? The first body, 100 degrees Celsius. That means m into C1 will be greater than m into C2. Okay, because temperature of the first body is greater than the temperature of the second body, therefore the heat capacity of the first body will also be greater than the heat capacity of the second body. Now since mass is same, so C1 will be greater than C2. So C1 by C2 ratio will be greater than 1. Okay, so since C1 is greater than C2, therefore C1 by C2 will be more than 1. Okay, this will be a positive value. This ratio will be a positive value. So when C1 by C2 is more than 1, that means this side, right hand side, will also be more than 1. Okay, therefore theta upon 100 minus theta will also be greater than 1. Now for what value of theta this whole value will be more than 1? It is only possible when theta is more than 50 degree. Okay, you can put different values of theta and check. If you keep any value of theta less than 50, then this value will become negative. Okay, so it has to be more than 50 degree. That means option C, more than 50 degrees Celsius. This will be the correct answer. Question number 70 is again from the chapter Thermal Properties of Matter, and the question is, a body cools from a temperature 3T to 2T in 10 minutes. The room temperature is T. Assume that Newton's law of cooling is applicable. The temperature of the body at the end of next 10 minutes will be. Okay, so we know that according to Newton's law of cooling, temperature change, that means T1 minus T2 upon the time taken, will be equal to K, that is a constant, into average temperature minus room temperature T. Okay, so we'll use this formula here. Okay, now we have two situations. In the first situation, that means in the first 10 minutes, the body cools from 3T to 2T. That means T1 is 3T and T2 is 2T. So we'll put these values in the given formula. Okay, so T1 minus T2, that means 3T minus 2T upon time, that means 10 minutes, equals to K, that is a constant, into average temperature, that means 3T plus 2T upon 2. This is the average temperature, minus room temperature, that is given as T. Okay, so let's solve it. This side we have 3T minus 2T, that means T by 10. This side K into 3T plus 2T by 2, that means 5T by 2. Okay, so 5 by 2T minus T. So what will we get on the right hand side? It will be K into 3 by 2T. Okay, on solving inside the bracket we'll get 3 by 2T. So from here we can say T will be cancelled, so the value of K will be equal to 1 by 15. Okay, we have got the value of K. Now in the next 10 minutes, this is the second part. This time the body cools from 2T to a certain temperature T dash. Okay, so T1 in this case will be 2T and T2 will be T dash. We have to find this temperature T dash. Okay. So let's put these values in the same formula again. So T1 minus T2, that means 2T minus T dash upon time, that is 10 minutes, equals to K into average temperature, that means 2T plus T dash by 2 minus room temperature, that is T. Okay. So let's solve the right hand side first, this bracket first. So it will be K into, we'll take the LCM 2. So it will be 2T plus T dash minus 2T. Okay. So 2T and minus 2T will be cancelled. Here we'll get K into T dash by 2. Okay. So on the left hand side we have 2T minus T dash upon 10, and on the right hand side we have K into T dash by 2. Okay. Now we'll solve it. Okay, we also know the value of K, right? So K is 1 by 15. We have seen in the first equation. So 2T minus T dash by 10 equals to 1 by 15 into T dash by 2. That means T dash by 30. Okay. Since K is equal to 1 by 15. So that you don't get confused from here. So let's solve it and find the value of T dash from here. 0 will be cancelled. So 3, this side will bring 3 this side. It will become 6T minus 3T dash, and this side we have T dash. So 6T equals to 4T dash. So from here we can say that T dash will be equal to 6T by 4. That means 3 by 2T. Okay. So this is the final temperature. Okay. 3 by 2T. That means option C will be the correct answer. Okay. Question number 71 is again from the same chapter, that is thermal properties of matter. And the question is, 1 mole of an ideal monoatomic gas undergoes a process described by the equation PV cube equals to constant. The heat capacity of the gas during this process is, okay. So we know that PV to the power x is constant. So according to this question, the value of x is 3 here. Okay. Now we'll use this value of x to find the heat capacity. We know that the heat capacity C is equal to CV, that is heat capacity at constant volume, plus R upon 1 minus x. Okay. R is the gas constant. Okay. So this you have to remember, this formula. C equals to CV plus R by 1 minus x, where x is the power here. Okay. So let's put the values here. C will be equal to CV. Now this is a monoatomic gas. So we know that for monoatomic gas, the value of CV is 3 by 2R. Okay. So C equals to CV, that means 3 by 2R plus R by 1 minus X, and X here is 3. Okay. So 1 minus 3. So what do we get? 3 by 2R plus R by 1 minus 3 means minus 2. Okay. So it can be written as 3 by 2R minus R by 2. Okay. So on solving this, what do we get? We'll get 2 by 2R, that means R. Okay. So C is equal to R. This is what we have got. So option A will be the correct answer. Okay. The value of heat capacity of the gas is equal to R. Okay. Question number 72 is from the chapter thermodynamics, and the question is, the temperature inside a refrigerator is T2 degrees Celsius and the room temperature is T1 degrees Celsius. The amount of heat delivered to the room for each joule of electrical energy consumed ideally will be. Okay, so we have two types of reservoir here. One is cold reservoir, that is the refrigerator. Okay, here the temperature is T2 degrees Celsius. In Kelvin it will be T2 plus 273 Kelvin, right? And the heat that will be released from the cold reservoir will be Q2. Okay, this is the heat released from the refrigerator. Okay, if we talk about the hot reservoir, what is the hot reservoir here? The room. Okay, it is room. So the room temperature is given as T1 degrees Celsius. That means here the temperature is T1 degrees Celsius, that is equal to T1 plus 273 Kelvin. Okay, and the heat that will be delivered to the hot reservoir, that is the room, will be Q1. Okay, this is the heat delivered to the room. Now what we have to find in this question, we have to find the amount of heat delivered to the room, that means Q1, for each joule of electrical energy consumed. So energy means work, okay, that is equal to work. So we have to find the heat delivered to the room, that means Q1, for each joule of electrical energy, that means Q1 by W. Okay, we have to find this. Now let's start solving the question. So we know that the coefficient of performance of refrigerator beta is equal to T2 by T1 minus T2 in terms of temperature, and in terms of heat it will be Q2 by W. Okay. So here what is the value of T2? This is T2 degrees Celsius. So in Kelvin it will be T2 plus 273 Kelvin, because we have to write in Kelvin. Okay. Divided by T1 minus T2. That means T1 plus 273 minus T2 plus 273, and on this side we have Q2 by W. Now we know that Q1 minus Q2 is equal to W. Okay, work done is equal to Q1 minus Q2. So in place of Q2 we can write Q1 minus W, right? So in place of Q2 we'll write Q1 minus W. Okay, why did we do this? Because we have to find Q1 by W. Okay, therefore, so let's solve it. On the left hand side we have T2 plus 273 upon T1 plus 273 minus T2 minus 273 on opening the bracket. Okay, so minus 273 and plus 273 will cancel out, and this side we have Q1 minus W by Q by W, that means Q1 by W minus 1. Okay, so this side we have T2 plus 273 upon T1 minus T2, and this side we have Q1 by W minus 1. Now here we have to find the value of Q1 by W, this one. Okay, so what will be the value of Q1 by W? That will be equal to T2 plus 273 upon T1 minus T2 plus 1. Okay, 1 will go this side in plus. So let's just solve it. T1 minus T2 will be the LCM, and this side we have T2 plus 273 plus T1 minus T2. Okay, so plus T2 and minus T2 will be cancelled, and what is left here? We have T1 plus 273 upon T1 minus T2. This is the value of Q1 by W, that is heat delivered to the room per unit work done or per unit energy consumed. Okay, so T1 plus 273 upon T1 minus T2. Let's see. Option number C. Okay, this is the correct one. T1 plus 273 divided by T1 minus T2. So option C will be the correct answer. Question number 73 is again from the chapter Thermodynamics, and the question is, a given sample of an ideal gas occupies a volume V at a pressure P and absolute temperature T. The mass of each molecule of the gas is m. Which of the following gives the density of the gas? Okay, so we know that for an ideal gas PV equals to nRT. So from here the number of moles N will be equal to PV upon RT. Okay, and number of moles can be written as given mass by molar mass, so that is equal to PV by RT. But we have to find the density of the gas, that means mass by volume. So we'll take the volume on the left hand side, okay, and we'll take molar mass on the right hand side. So mass by volume equals to P into molar mass upon RT. Okay, so this is the density on the left hand side, mass by volume. But here we have gas constant, and in the options all the options are given in terms of Boltzmann constant K, not in gas constant R. Okay, so we'll convert it to get the Boltzmann constant K. We know that the molar mass can be written as given mass by number of moles, and the reciprocal of number of moles is equal to Avogadro number. So this can be written as given mass into Avogadro number. Okay, so let's write it P into molar mass. So in place of molar mass we'll write given mass into Avogadro number upon RT. Now we know when the gas constant R is divided by the Avogadro number, it gives the Boltzmann constant. Okay, so we have Na by R, Avogadro number by R, that means K will come on the denominator side here. So Pm upon Kt, this will be the value of density. Okay, so let's see which option has this. Pm upon Kt, that means option C, right? Option C is the correct answer. Question number 74 is from the chapter Oscillations, and the question is, a body of mass m is attached to the lower end of a spring whose upper end is fixed. The spring has negligible mass. When the mass m is slightly pulled down and released, it oscillates with a time period of 3 seconds. When the mass m is increased by 1 kg, then the time period of the oscillations become 5 seconds. So the value of m in kg is, okay. So initially the mass was m kg, that means m1 is m, and after some time it has been increased by 1 kg, that means m2 is m plus 1, okay. When the mass was m, then the time period was 3 seconds, so t1 is 3 seconds, and when the mass is m plus 1, then the time period becomes 5 seconds, okay. So 5 seconds, t2 equals to 5 seconds. Now we know that the time period will be equal to 2 pi under root m by k, okay. M is the mass, K is the spring constant. So T is proportional to root M, right? That means T1 by T2 will be equal to under root M1 by under root M2. Okay. So M1 is M, that means under root M, upon M2 is M plus 1, that means M plus 1. Okay. So T1 is 3 seconds, T2 is 5 seconds, equals to under root M upon under root M plus 1. Now we have to solve it. So let's square both the sides. Okay. So on squaring both sides, because we have to remove the root. Okay. What will we get? We'll get 9 by 25 on the left hand side, and this side M by M plus 1. Now we can cross multiply. So we'll get 9 into M plus 1 equals to 25M. Okay. So 9M plus 9 equals to 25M. So 25 minus 9M, that means 16M will be equal to 9. So what will be the value of M? It will be 9 by 16 kg. Okay. So this is the value of mass in kg, that means 9 by 16. So let's see which option is the correct one. First one, okay, 9 by 16 kg. Option A is the correct answer. Question number 75 is from sound waves, and the question is, the second overtone of an open organ pipe has the same frequency as the first overtone of a closed pipe L meter long. The length of the open pipe will be, okay. So we know that for an open organ pipe, the frequency pattern is N0, 2N0, 3N0, 4N0 and so on, okay. And for closed organ pipe, the frequency pattern is N0, 3N0, 5N0, 7N0, etc. Okay, that means there are odd numbers. Okay, and the value of N0 for open pipe is equal to V by 2L, and that for the closed pipe is V by 4L. Okay, now let's assume that the length of the open pipe is L dash. So let's write it as L dash, and for closed pipe it is given that the length is L. Okay. Now, what else is given? The second overtone of an open organ pipe, that means 2N0 is the first overtone and 3N0 is the second overtone. Okay, so 3N0. This has the same frequency as the first overtone of the closed pipe, that means 3N0. Okay, so 3N0 is equal to 3N0. First one is for open pipe and the second one is for closed. Okay, so what is the value of N0 for open pipe? It is V by 2L dash. And this side we have 3 into N0 for closed is V by 4L. Okay. So V cancelled, 3 cancelled. That means 2L dash equals to 4L. Okay. Now we have to find the length of the open pipe, that means L dash. So L dash equals to 4L upon 2, that means 2L. Okay. So 2L, that means option C is the correct answer. Got it? Question number 76 is again from sound waves, and the question is, three sound waves of equal amplitudes have frequencies n minus 1, n and n plus 1. They superimpose to give beats. The number of beats produced per second will be. So number of beats produced per second means beat frequency. Okay. So we have to find the beat frequency. Okay. Now, what is the formula for beat frequency? Beat frequency is equal to N2 minus n1. Okay, these are frequencies for two frequency, but here you can see there are three frequencies. So for that we have to take maximum and minimum values. So maximum value, that means n plus 1, minus the minimum value, that means n minus 1. Okay, so if we solve it, n plus 1 minus n plus 1. Okay, minus minus will become plus. So plus n and minus n cancelled. 1 plus 1, that is 2. This is the beat frequency, that means number of beats produced per second. That means option A will be the correct answer. Question number 77 is from the chapter Electric Charges and Fields, and the question is, an electric dipole is placed at an angle of 30 degree with an electric field intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter, is, okay. So we know that the torque is equal to Pe sine theta. Torque is given as 4 Newton meter. The P, that is dipole moment, is unknown. Electric field intensity E is given as 2 into 10 to the power 5 Newton per coulomb. Okay, and sine theta. Theta is 30 degree here. Okay, so sine 30 degree means half. So 2 and 2 cancelled. So we can say that the dipole moment P is equal to 4 into 10 to the power minus 5. Okay. The unit of dipole moment is coulomb meter because it is the product of charge and length. So dipole moment is equal to charge into length of the dipole. So length of the dipole is given as 2 centimeter. Okay. So the dipole moment 4 into 10 to the power minus 5 is equal to charge into the length of the dipole, that means 2 centimeter. So it can be written as 2 into 10 to the power minus 2 meter. Okay. So what will be the value of Q? That will be equal to 4 into 10 to the power minus 5 upon 2 into 10 to the power minus 2. Okay. So we'll get 2 into 10 to the power minus 5 plus 2, that means minus 3. Okay. And the unit of charge is coulomb. So it can be written as 2 mini coulomb. 10 to the power minus 3 means mini coulomb. Okay. So option C, 2 milli coulomb, will be the correct answer. Question number 78 is from the chapter Electrostatic Potential and Capacitance, and the question is, a parallel plate capacitor of area A, plate separation D and capacitance C is filled with four dielectric materials having dielectric constants K1, K2, K3 and K4 as shown in the figure below. If a single dielectric material is to be used to have the same capacitance C in this capacitor, then its dielectric constant K is given by, okay. So what is the formula for capacitance? That is equal to K epsilon naught A by D, where A is the area and D is the distance. Okay. K is the dielectric constant, right? Now here we have four dielectric constants. You can see that the distance of separation between the plates is D. Look at this figure. Okay. In the distance D by 2, that means half of the distance, three dielectric materials are kept having the constants K1, K2 and K3. Area of these three is A by 3 and the distance D by 2, and the fourth one is kept below them. Okay, this has the dielectric constant K4. Its area will be A, not A by 3, because in the upper part the area was divided into three dielectric materials, but in the lower part only one dielectric material occupies the area, so it will have the area A and the distance will be D by 2. Okay. So let's find the capacitance in each case. For the first one, the capacitance C1 will be equal to K1 epsilon naught A by 3 upon D by 2, because the area is A by 3 and distance is D by 2 for the first three dielectric materials. Okay, so this will be equal to 2 by 3 epsilon naught A by D into K1. Okay, similarly for the second one, C2 will be equal to 2 by 3 epsilon naught A by D into K2. And for the third one, C3 will be equal to 2 by 3 epsilon naught A by D into K3. Okay. Now these three dielectric materials are arranged in parallel combination. That means C1, C2 and C3 are in parallel combination. It means that the equivalent of these three, let's say C dash, will be equal to C1 plus C2 plus C3. Now 2 by 3 epsilon naught A by D is common, so that can be taken outside the bracket, and inside the bracket we'll have K1 plus K2 plus K3, isn't it? So this is the equivalent of the first three capacitances. That means capacitance of the three dielectric materials. But the fourth one is also there. Okay. And these two are in series combination. That means C dash and C4 are in series combination. What is the value of C4? C4 is equal to K4 epsilon naught A upon D by 2. Okay. That means 2 K4 epsilon naught A by D. Okay, because for the fourth one the area was A and the distance was D by 2, right? So these two are in series combination. So 1 by C equivalent, 1 by C equivalent will be equal to 1 by C dash plus 1 by C4, because we know that for series combination of capacitance we use this formula. Okay, it is given that if we use a single dielectric material instead of these four dielectric material, then what will happen? The capacitance of that single dielectric material will be same as this capacitance, the equivalent of these four. Okay, so this, in place of equivalent we can write the capacitance. We know that C is equal to K epsilon naught A by D. So the reciprocal 1 by C equivalent will be equal to D by K epsilon naught A. Okay, this is equal to 1 by C dash, reciprocal of C dash, that means 3 by 2 D upon epsilon naught A into K1 plus K2 plus K3 plus 1 by C4. So the reciprocal of C4, that means D by 2 K4 epsilon naught A. So D can be cancelled. It is on both the sides. Epsilon naught A can also be cancelled. So what is left now? On the left hand side we have 1 by K, and this side we have D by 2 into K1 plus K2 plus K3, plus this side we have 1 by 2 K4. Okay, so 1 by 2 is common on the right hand side, so that 2 can be taken on the left hand side as 2 by K. Okay, so 2 by K equals to, what is left on the right hand side? We have 3 upon K1 plus K2 plus K3 plus 1 by K4. So this expression is mentioned in the options. Which option? The last one. Okay, 2 by K equals to, this is equals to sign, 3 upon K1 plus K2 plus K3 plus 1 by K4. Okay, this is the same expression. So option D will be the correct answer. Question number 79 is from the chapter Current Electricity, and the question is the potential difference VA minus VB between the points A and B in the given figure is. Okay, so we have 2 points, point A and point B. Potential here is VA and this side we have VB. Current is 2 ampere. Okay, 2 ampere current is flowing. Here we have a resistance, 2 ohm resistance. Then we have a battery. This is the positive terminal, this is the negative terminal. Again we have a 1 ohm resistance. Now suppose that these 2 points are connected by a battery. This is the positive terminal, this is the negative terminal. Okay, positive and negative terminal. So we have to find VA minus VB. That means this VAB, potential of this battery that connects the point A and B. Okay, so we'll use the Kirchhoff's voltage law here. Okay, suppose this is the direction of the current. So from here, we'll start from here. You can see that the current starts moving from negative to positive terminal. That means it will be plus VAB. When we move towards positive, it is positive, and when we move towards negative, it is negative. Okay, but after that, after it comes here 2 ohm resistance, it becomes negative, because here we are moving from positive to negative terminal now. Okay, so minus, what is the voltage? 2 ohm resistance into 2 ampere current, so 2 into 2. Again minus sign, this is a 3 volt battery. Okay, this is missing in the figure. Here it is a 3 volt battery, so minus 3 volt. Again minus sign, we have a 1 ohm resistance, so 2 ampere current and 1 ohm resistance, so voltage will be 2 into 1 and the sum will be 0. Okay, so VAB minus 4 minus 3 minus 2 equals to 0. That means VAB minus 9 volt is 0. We are taking voltage only, right? So VAB is equal to 9 volt. So plus 9 volt will be the correct answer. Okay, we don't have a negative sign here. So option A will be the correct answer. Question number 80 is again from the chapter current electricity, and the question is a filament bulb 500 watt 100 volt is to be used in a 230 volt main supply. When the resistance R is connected in series, it works perfectly and the bulb consumes 500 watt. The value of R is, okay, so we have a bulb here whose power is given as 500 watt and the voltage is given as 100 volt. Then a resistance R is connected in series with this. The mains supply is 230 volt. Okay, this is the 230 volt mains supply. Now if we talk about the bulb, so power is given, voltage is given. We can find out the resistance and current. So P is equal to V square by R. You know this formula. So from here R will be equal to V square by P, right? V square means 100 square. So 100 into 100 upon the power P, that means 500. So this will be equal to 20 ohm. Okay, resistance of this bulb is 20 ohm. Similarly, we can find out the current by using the formula P equals to VI. So current I will be equal to P upon V. Power is 500 and voltage is 100. So this will be equal to 5 ampere. Current of this bulb, current passing through this bulb is 5 ampere and the resistance is 20 ohm, right? Now the resistance R is connected in series with this. That means the same current will flow through this resistance R. Okay, so the current at this resistance will also be 5 ampere. Now it is given that when this resistance is connected in series, then this works perfectly and the bulb consumes 500 watt. Okay, so when the bulb is consuming 500 watt, that means the voltage across this bulb will be 100 volt, right? And the mains voltage is 230 volt. So the voltage at this bulb plus the voltage at this resistance R will be equal to the mains voltage, that is 230 volt. Okay, so what will be the voltage at this resistance R? That will be equal to 230 minus voltage of the bulb, that is 100 volt. Okay, so that is equal to 130 volt. Now if we talk about the resistance R, so here the voltage is 130 volt and the current passing is 5 ampere. So what will be the resistance? Resistance R will be equal to potential, the voltage at this R divided by the current, and we have seen that it is 130 volt upon the resistance, that is 5 ampere. So that will be equal to 26 ohm. Okay, the value of this resistance is 26 ohm. That means which option will be the correct one? Option number D is the correct answer. Question number 81 is from the chapter Magnetic Effects of Current, and the question is a long wire carrying a steady current is bent into a circular loop of 1 turn. The magnetic field at the center of the loop is B. It is then bent into a circular coil of n turns. The magnetic field at the center of this coil of n turns will be. Okay, so we have two cases here. In the first case, a long wire that is carrying a steady current is bent into a circular loop of how many turns? 1 turn. Okay, so n is equal to 1. Now suppose the radius of this loop is capital R. Then we know that the magnetic field at the center of a circular loop carrying a current is given by mu naught Ni upon 2R. But here n is equal to 1, right? Because we have only one turn in this case. So it can be written as B equals to mu naught I upon 2R. Right, this is the magnetic field at the center of the first loop. Okay, now after that the same wire is bent into n number of loops, then definitely the size of the loop will decrease. Okay, let's say this is the size of the new loop which has n number of turns, and let's assume that the radius is small r. So what will be the value of small r in terms of capital R? We know that the total length of the wire will remain same, right? That means the perimeter of the bigger loop, that is 2 pi r, will be equal to n times the perimeter of the smaller loop, right? N into 2 pi small r. Got it? So 2 pi can be cancelled. That means capital R is equal to n times small r, or we can write small r is equal to r by capital R by n. Okay. So this is the value of radius of the smaller loop. Okay. So we can put this value in the formula. What will be the magnetic field at the center of this smaller loop? It will be mu naught Ni upon 2r, small r, okay, and here small r is equal to capital R by N. So let's put that value, mu naught Ni upon 2 capital R by N. So N will go up, it will become N square into mu naught I upon 2r, okay. So can we say that mu naught I by 2r is equal to B? So it can be written as N square times B, okay. If B dash is the magnetic field at the center of the smaller loop, then B dash is equal to N square times the magnetic field of the bigger loop, okay. So option C, N square times B, will be the correct answer. Question number 82 is from magnetism and matter, and the question is, a bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field and is in equilibrium state. The energy required to rotate it by 60 degrees W. Now the torque required to keep the magnet in this new position is, okay. So we have a bar magnet that was initially in equilibrium state in the uniform horizontal magnetic field. That means the angle theta was equal to 0 degree, okay, initially. But after that it is rotated by 60 degree. That means theta becomes 60 degree. Now initially when the angle was 0 degree, what was the potential energy? That is, initial potential energy was minus mb cos theta, right? This is the formula. So cos theta, theta is 0 degree here, so cos 0 degree means 1. So that is equal to minus mb. This is the initial potential energy. What will be the final potential energy? That means when the angle is 60 degree, this will be equal to minus mb cos 60 degree, and cos 60 degree is equal to 1 by 2. So the final potential energy will be equal to minus mb by 2, okay. So let's say this is number 1, this is number 2. We know that the work done is equal to change in energy, okay. That means final potential energy minus initial potential energy. Final is minus mb by 2 minus initial is minus mb. So minus minus will become plus. So minus mb by 2 plus mb, and on solving this you will get mb by 2, okay. So this is the work done. Got it? Work done is mb by 2. That means the value of mb is 2 times the work done, okay, 2w. But we have to find the torque required to keep the magnet in the new position. That means 60 degree angle, okay. So torque is equal to mb sine theta. The value of mb is 2w, and sine theta means sine 60 degree, okay. What is the value of sine 60 degree? Root 3 by 2. So 2w into root 3 by 2. So 2 will be cancelled. This is root 3 times w, okay. So the torque required to keep the magnet in the new position, that is at an angle of 60 degrees, root 3 times the work done, w. So option C, root 3w, will be the correct answer. Question number 83 is again from magnetic effects of current, and the question is, an electron is moving in a circular path under the influence of a transverse magnetic field of 3.57 into 10 to the power minus 2 Tesla. If the value of E by M is 1.76 into 10 to the power 11 Coulomb per kg, the frequency of revolution of the electron is, okay. So the value of magnetic field B is given as 3.57 into 10 to the power minus 2 Tesla, and the ratio of charge and mass of the electron, that is E by M, is given as 1.76 into 10 to the power 11 Coulomb per kg. We know that the centripetal force on the electron will be equal to the magnetic force on the electron. Centripetal force means mv square by r, and magnetic force means charge on the electron into velocity into the magnetic field, okay. So this v will cancel out the square. What will be the value of v by r? V by r will be equal to eb upon m. Now we know that v by r is nothing but the angular velocity omega. So we can say that omega is equal to eb upon m. But we have to find the frequency of revolution, right? So in terms of frequency, what is the value of omega? Omega is equal to 2 pi into frequency. So frequency will be equal to omega divided by 2 pi. That means this value divided by 2 pi. Okay. So frequency is equal to omega by 2 pi. That means EB upon m into 2 pi. Now the value of E by m is given here. This is equal to 1.76 into 10 to the power 11 coulomb per kg into magnetic field is also given 3.57 into 10 to the power minus 2 Tesla upon 2 pi is left here. So 2 into 3.14. Okay. Now you have to solve this, and after solving this you will get 0.9 into 10 to the power 9. Okay. That means 10 to the power 9 means giga and the unit is hertz. So 0.9 gigahertz. Okay. It is equal to 0.9 gigahertz, but this is not given in the options. So we'll choose the closest one. Closest one is the second option, 1 gigahertz, because 0.9 can be rounded off to 1 gigahertz. Okay. So this is 1 gigahertz frequency. Okay. So option B will be the correct answer. Question number 84 is from the chapter Alternating Current, and the question is, which of the following combinations should be selected for better tuning of an LCR circuit used for communication? Okay. So for better tuning, the quality factor must be high. Quality factor, what is the formula of quality factor? It is equal to 1 by R under root L by C. Okay. So we have to check in the given options which one has the maximum quality factor. Okay. So for quality factor to be maximum, the value of R should be minimum because it is on the denominator side. Value of C should also be minimum, but the value of L should be highest. Okay. So let's check. In the last option, option number D, the value of R is minimum 15 ohm. The value of L is maximum 3.5 Henry. Okay. All others are less than this. And the value of C is also minimum 30 microfarad. Others are 45, 35, 45. Okay. So here you can see that the value of R and C are minimum and the value of L is maximum. That means it will give the maximum quality factor. That means the tuning will be best in this case. So option D will be the correct answer. Question number 85 is from the chapter Electromagnetic Induction, and the question is, a uniform magnetic field is restricted within a region of radius small r. The magnetic field changes with time at a rate dB by dt. Loop 1 of radius capital R, that is greater than small r, encloses the region R, and loop 2 of radius R is outside the region of magnetic field as shown in the figure below. Then the EMF generated is, okay. So you can see we have two loops here, loop 1 and loop 2. Okay, this is the first loop, this is the second loop. Both the loops have radius capital R, but the region in which the magnetic field is present, that is located inside the loop 1, and that region has radius small r. Okay, so we have to check the EMF generated in each case. Okay, so in the first case, that means in loop 1, what will be the EMF? We know that flux is equal to the magnetic field into area. That means magnetic field B into pi r square, and which are the radius of the region in which the magnetic field is present, that is small r. Okay, because outside region there is no magnetic field, so that will not be considered. Okay, now we have to find the EMF. So EMF is equal to minus d phi by dt. That means differentiation of this phi. Okay, so minus pi r square is constant and dB by dt. This is the EMF generated in the first loop. Okay, and in the second case, when there is no magnetic field, okay, because it is given that this loop 2 is outside the region of magnetic field, right? So in this case, magnetic field is 0. When the magnetic field will be 0, then flux will also be 0. Okay, and when the flux is 0, then EMF will also be 0. Okay, so it is minus pi r square dB by dt in case of the first loop and 0 in case of second loop. Okay, so let's check. In the first one, it is given minus dB by dt into pi r square in loop 1 and 0 in loop 2. Yes, this is correct, right? In the second one, it is given 0 in loop 1. So this is not correct, okay? Because loop 1 has some EMF. In the third one, minus dB by dt pi r square in loop 1, this is correct, and minus dB by dt pi r square in loop 2, this is not correct because loop 2 has 0 EMF. Okay, in the last one, this is capital R, this will not be there, small r will be there because in the region where the magnetic field is present, only that region has to be considered. Okay, so option A will be the correct answer. Question number 86 is from the chapter Alternating Current, and the question is the potential differences across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit. The power factor of this circuit is, okay, so we have the potential difference across the resistance 80 volt. It can be written as I into R. Similarly, the potential difference across the capacitance is 40 volt. It is equal to I into XC. Okay. And the potential difference across the inductance is 100 volt. It can be written as I into XL. Now we have to find the power factor. So power factor is equal to cos phi, and that is equal to R by Z. Okay. So R by Z, what is the formula of Z? It is under root R square plus XL minus XC whole square. Right. Now here the values of R, XL and XC are not given. Instead, the values of potential differences are given. Okay. That means IR, IXC and IXL. So if we multiply and divide this expression R by Z by the current I, then it will be equal to IR upon IZ. Okay, that will be same as the cos phi. Okay, or the power factor. So in place of IR and IZ, we can write V by VZ. Okay, that means in this formula, if we don't have the value of resistance, we can put the values of potential difference also, because this will also fit here. So let's put the values. R, that means 80 volt here, upon under root R square, that means 80 square, plus XL, that means this 100, minus XC, that is 40 whole square. Okay, so on solving this, you'll get 80 by 100, that means 0.8. Okay, this will be your power factor. So option D will be the correct answer. Question number 87 is related to electromagnetic waves, and the question is a 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, the peak value of the displacement current is, okay. So since the peak value of the current is asked, so this percentage of the capacitor charged doesn't matter. Okay, now resistance is given as 100 ohm, and the reactance of the capacitor, that is Xc, is also 100 ohm. So what will be the value of Z? Z will be equal to under root R square plus Xc square. We don't have an inductor here, so it will be simply under root R square plus Xc square. So this is under root 100 square plus 100 square. If you solve this, you will get 100 root 2. Okay, so this is the value of Z. Now the voltage is given as 220 volt. It is not mentioned whether it is the peak voltage or the RMS voltage. So it will be assumed that it is the RMS voltage. Okay, this is 220 volt. But we have to use the peak voltage because peak value of the displacement current is asked. Okay, so V naught, peak value of the voltage will be 220 root 2 volt. Okay, VRMS into root 2. Now we have to find the peak current. So peak current will be equal to peak voltage divided by Z. Okay, that means 220 root 2 upon 100 root 2. So root 2 cancelled. 22 divided by 10, that means 2.2, and the unit of current will be ampere. So 2.2 ampere, that means option B will be the correct answer. Question number 88 is from the chapter Ray Optics and Optical Instruments, and the question is two identical glass equiconvex lenses of focal length f each are kept in contact. The space between the two lenses is filled with water. The focal length of the combination is, okay. So we have two identical glass equiconvex lenses. Okay, suppose this is one of the convex lens, this is another convex lens. Okay, equiconvex means both the radius of curvature will be same. That means R1 will be equal to R2. Okay, let's say this will be R. Okay, now these two are kept in contact and the space between them is filled with water. Okay, like this. So if you look at the shape of the water, it will look something like this, right? That means water can behave as a concave lens. Okay. So instead of two lenses, we can assume that there are three lenses. First one is convex, then water, that is a concave lens, and then another one that is convex lens. Okay. We have to find the focal length of combination of three lenses. Okay. Now here you have to keep few things in mind. That means the sign convention. Okay. That is the most important thing. You have to remember that if the radius of curvature is on the left side of the center of curvature, left side of center of curvature, then it will have a positive sign. Okay. And if the radius of curvature is on the right side of the center, then it will have negative sign. Okay. For example, if we talk about the convex lens, this is R1, this is R2. Where will be the center? Center will be somewhere here. Okay. So R1 is on the left side of the center. That means R1 will be positive, and R2 is on the right side of the center, so R2 will be negative. This is for convex lens. But for concave lens, this is the concave lens. Here, where will be the center? This is the center of the left one. Okay, so center is here. So this time R1 will be negative because this R1 is on the right side of the center and the center of the other one will lie here. Okay, so the second face is on the left side of the center. That means R2 will be positive. Okay, so we have seen that for convex R1 will be positive, R2 will be negative, but for concave R1 will be negative and R2 will be positive. Okay, just opposite. Now let's start. We know the lens maker formula, 1 by f equals to mu minus 1 by R1 minus 1 by R2. This is the lens maker formula. So if we talk about the convex lens, okay, convex lens, for that 1 by f will be equal to mu minus 1. Mu is the refractive index, so it is given as 3 by 2 for the convex lens. Okay, so 3 by 2 minus 1 by R1 minus 1 by R2, and we have seen that R1 is equal to R2 and that is equal to R. Okay, so 1 by R minus 1 by minus R, because we have seen that for convex lens R2 is negative. Okay, so 3 by 2 minus 1, that means 1 by 2, and this side we have 1 by R minus 1 by minus R, that means 1 by R plus 1 by R. Okay, so it will become 2 by R, so 2 by R, and on solving this we'll get 1 by R. Okay, so 1 by f is equal to 1 by R. That means f will be equal to R, right? So this is important, this you have to keep in mind. Now we'll talk about the concave lens. For concave lens, we'll use the same formula. Let's say this time the focal length is f dash. Okay, so 1 by f dash will be equal to mu minus 1, that is 4 by 3 minus 1, because for the concave lens, that is for the water, the refractive index is given as 4 by 3. Okay, 1 by R1 minus 1 by R2. So we have seen that for concave, R1 will be negative, that means 1 by minus R, minus R2 will be positive, so minus 1 by R. Okay, now on solving this, 4 by 3 minus 1, that is 1 by 3 into 1 by minus R minus 1 by R, that means minus 2 by R. Okay, so into minus 2 by R, so minus 2 by 3R. Okay, this is the value of 1 by f dash, but we have seen that f is equal to R. So in place of R we can put f, right? So this is equal to minus 2 by 3f. Okay, this is the value of 1 by f dash in terms of f, because all the options are given in terms of f. Okay, now we have to find the focal length of the combination. F equivalent will be equal to 1 by f plus 1 by f for two convex lenses, plus 1 by f dash for the concave lens. Okay, so 1 by f plus 1 by f means 2 by f, plus 1 by f dash is equal to minus 2 by 3f. We have just calculated, so minus 2 by 3f. So on solving this, what do we get? It will be 3f. Here we have 6 minus 2, that means 4 by 3f. Okay, this is what? 1 by, okay, this was 1 by f equivalent, okay, 1 by f equivalent was equal to 1 by f plus 1 by f plus 1 by f dash. So 1 by f equivalent is equal to 4 by 3f, okay. So what will be the value of f equivalent? It will be 3f by 4, just the reciprocal. So the focal length of the combination will be 3f by 4, okay. So let's check the options. 3f by 4 in option number A we have this. So option A will be the correct answer. Now question number 89 is again from ray optics and optical instruments, and the question is an air bubble in a glass slab with a refractive index 1.5 near normal incidence is 5 cm deep when viewed from one surface and 3 cm deep when viewed from the opposite face. The thickness in centimeter of the slab is, okay. So suppose this is the slab, glass slab, and its thickness is t centimeter, okay. This is the thickness, t centimeter. An air bubble is present inside the slab. Suppose this is present here. This is surface 1, this is surface 2, okay. Now if the depth of this air bubble from the surface 1 is x, then what will be the depth of this air bubble from surface 2? It will be t minus x, right? Now it is given, then when viewed from one surface, let's say surface 1, then it seems to be at 5 centimeter deep, and we know that the actual depth will not be seen, okay. The apparent depth that will be visible, apparent depth that will be experienced by the viewer will be equal to the actual depth divided by the refractive index of the medium, right? So from surface 1, the apparent depth d1 dash will be equal to x by mu, okay, because the actual depth from the surface 1 is x, okay. So x divided by mu, and that is given as 5 centimeter, okay. And from surface 2, the apparent depth d2 dash will be equal to t minus x by mu, because the actual depth from this surface is t minus x, okay. So t minus x by mu, and that is given as 3 centimeter, okay. Now we have to find the depth, the thickness, total thickness of the slab t, okay. So if we add them up, d1 dash plus d2 dash will be equal to x by mu plus t minus x by mu, that will be equal to 5 centimeter plus 3 centimeter, okay, that is 8 centimeter. So we can say that x minus x plus t minus x, so plus x minus x will be cancelled, so t by mu will be equal to 8 centimeter. So what will be the thickness t? That will be equal to 8 mu, and the mu, that means the refractive index of the medium is given as 1.5, okay. So 8 into 1.5, that means 12 centimeter. This will be the thickness of the slab t, okay. So 12 centimeter will be the answer. Which option? Option number D will be the correct answer. And now the last question is from the chapter Wave Optics, and the question is, the interference pattern is obtained with two coherent light sources of intensity ratio n. In the interference pattern, the ratio I maximum minus I minimum upon I maximum plus I minimum will be, okay. So we know that for constructive interference, I maximum is given as under root I1 plus under root I2 whole square, and I minimum is given as root I1 minus root I2 whole square, okay. So using these two, we can find out the ratio I maximum minus I minimum upon I maximum plus I minimum, right? Let's put the values. I maximum means root I1 plus root I2 whole square minus I minimum means root I1 minus root I2 whole square upon I maximum root I1 plus root I2 whole square plus I minimum, so plus root I1 minus root I2 whole square, okay. Now let's open the bracket. Root I1 plus root I2 whole square, that means A plus B whole square. So A square, that means I1, plus B square, that is I2, plus 2AB. So 2 root I1 root I2, okay, minus A minus B whole square. So I1 plus I2 minus 2 root I1 root I2 upon Here we have a plus b whole square again. So I1 plus I2 plus 2 root I1 root I2 plus a minus b whole square. So I1 plus I2 minus 2 root I1 root I2. Okay. Here we have not given the bracket because this is a plus sign here. Okay. If it had been minus sign, then the value would change. But here no need to change that. So on the denominator side, plus 2 root I1 root I2 will cancel out this minus 2 root I1 root I2. Okay. And on the numerator side, if you open the bracket, this I1 will cancel out this minus I1 and this I2 will cancel out this minus I2. Okay. So what will be left on the numerator side? 2 root I1 root I2, and this side minus minus will become plus. So plus 2 root I1 root I2, it will become 2 plus 2, that is 4 root I1 I2. Okay. And on the denominator side we have 2I1 plus 2I2. Okay. So we can take 2 common and under bracket I1 plus I2. Okay. This 2 into 2 is 4. So 2 root I1 I2 under root upon I1 plus I2. Okay. But this is not the answer because the answer is in terms of n. Okay. So we have to find the answer in terms of n, and it is given that I1 by I2, that is the ratio of intensities, is equal to n. Okay. So let's divide the numerator and denominator both sides by I2 to get the desired result. Okay. So on dividing the numerator and denominator by I2, because we have to get the value I1 by I2, okay, so that we can substitute it by n. Okay, so let's see. On the numerator side we have 2 root I1 I2. Okay, so dividing by I2. Okay, and on the denominator side we have I1 plus I2, so this will also be divided by I2. Let's see what do we get. So on the numerator side, this I2 is not under the root, right? So if we take it inside the root, it will become I2 square. Okay. So 2 under root I1 I2 upon I2 square. And on the denominator side, we have I1 plus I2 by I2, that means I1 by I2. And this will become I2 by I2, that means 1. Okay. On the numerator side, we'll get 2. Here this I2 will cancel out the square, and what will be left? Root I1 by I2. Okay. And this side we have I1 by I2 plus 1. Now we know that I1 by I2 is equal to n. So we can write it as 2 root n upon n plus 1. Right. So this will be the desired result. 2 root n upon n plus 1. Let's check. In the first option we have 2 root n upon n plus 1 square. No, square will not be there. In the second option we have root n. No, we have to get 2 root n. Okay. In the third option we have 2 root n upon n plus 1. Yes, this is the result. Okay. So option C will be the correct answer. Okay. So here we complete all the physics questions from NEET 2016 phase 2 paper. Okay. So that's it for today. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice the same questions from our website www.examsnet.com, and for more information, download our app from the link given in the description box. Thank you so much.